All right, so the second period solution set, which is the 2, 5, 8, 11, ... set. If you're looking for the others, they're posted elsewhere. 1 and 2 are very similar, so we kind of work them together here. It's the same function. It's both MVT, but one of them is -1/2 to 1, and one of them is 1/2 to 1. They're intervals. Now, I nearly messed this up during first period doing number 1, so if you want to watch me head down the wrong path and then catch myself before I get the wrong answer anyway, go watch that video and see me flounder around a little bit before I get there. If I want to use MVT, first, test taking strategies in general. Look at your answers, see what's going on there, see if anything stands out as, whoa, MVT is not guaranteed. So what has to be true for MVT to work? There's 2 conditions to use MVT. What are they? Do you remember what has to be true for the calc slope to equal the algebra slope? It's got to be continuous on the closed interval and differentiable on the open interval. Okay, well 1/x, that's a problem right there. This thing is not continuous at x equals 0. I don't know what's going on there. I guess it's probably an asymptote, but I can't plug in 0, so whatever's happening there, it is not continuous. So I don't even have to go on. This is not going to work. Now, for number 2, our interval does not include 0. So yes, this thing is not continuous at 0, but we don't care because 0 is not in our interval. So number 1, we just had to throw out and say MVT doesn't work. Number 2, it's all right, this is a real MVT problem. My answer is not going to be D. My answer is going to be something else. So now let's actually work the MVT problem where calc slope equals algebra slope, and we figure out where that is. Little side note, I want to work this problem, but if you're really paying attention, you can get the answer to number 2 without doing much more. We'll come back to that in a minute. All right, calc slope equals algebra slope. So algebra slope, that's y2 minus y1 over x2 minus x1. So let's plug in 1/2 and 1 and see what we get. Plug in 1/2. 2 times 1/2 is 1. 1 over 1/2, so just flip the 1/2, we get 2. So that's 3. If I plug in 1, I get 2 plus 1 is also 3. So my algebra slope is going to be 3 minus 3 over 1 minus 1/2. So that worked out nice. My algebra slope is 0. Thank you. My calculus slope, I think I'm going to rewrite this. So many people mess up the derivative of 1 over x. So it might be helpful to rewrite it as x to the -1, because then it's a power rule thing, and you're not trying to figure out what 1 over x is. So that's 2 minus x to the -2. So 2 minus 1 over x squared is my calculus slope. So this is sort of bad form here. Wouldn't matter on multiple choice, but you'd be better off labeling things. Thank you. So here's my sort of my main point of the MVT, is that the calculus slope equals the algebra slope. So 1 over x squared equals 2. So if I guess, cross multiply, I get x squared equals 1/2. So x equals plus or minus the square root of 1/2, which is what answer choice A says. But why is that not right? Right, the negative one is not in the range, so I can't use the negative one. So it's answer choice B. Okay, back to what I was saying earlier. Speaking of the range, once I know that MVT works, I throw out D. And look at my remaining answers. Only one of them is on the range. So it had to be B from the very beginning. That's the only one that would have worked. Number 5. For what values of x is f decreasing? Okay, so f decreasing, that, again, my brain should be thinking f decreasing means f prime is negative. So I need to take a derivative, figure out where it's 0, set up the number line, test the intervals, see what happens. Decreasing. Product rule. So again, you got to know all those old rules. You still got to use those. So let's see. It doesn't really matter the order, right? Just one of the derivatives times the original plus the other way around. So I'll do f times g prime plus f prime times g. So I can factor out e to the negative x squared. That leaves 2x squared plus 1, which makes me think I did something wrong. I did do something wrong. I knew it was wrong because this is never going to be 0, so that would be a problem. When I took the derivative of negative x squared should be negative 2x.
Can you scoot the page up?
Which way? So is that good?
Yeah.
Okay, e to the negative x squared. E to something is never going to be negative, so I don't have to worry about that. Right? Like negative x squared, that's weird. E to the negative x squared, that's weird. But e to some power is always positive, so I don't have to worry about it. 2x squared equals negative 1. That means, or no, 2x squared would equal positive 1. So x squared equals 1/2. So x equals plus or minus the square root of 1/2. So those are my critical points. Potential maxes and mins. So I can throw out C and D. It's got to be A or B. And so now it's just a matter of, running out of room, but I don't know what those values are. Like I don't know what that equals, but I know a good value that's in between the two to test. What's a good number between negative square root of 1/2 and positive square root of 1/2? 0. So let's test 0. Weird numbers, but I still get to test nice numbers. And I'm going to test it into f prime, so let's be careful. E to the 0 is 1, so that's not a problem. And then negative 2 times 0 squared, that's just 0, plus 1 is positive. And then if I'm interested in saving time and I trust the alternating rule, I can alternate after that. Because neither of those are double roots. is a plus or minus square root, but each of those are single roots. There was not a double root in there. If I wanted to check, again, I don't know what the square root of 1/2 is, but I'm pretty sure it's less than 1. So I could check 1 and I'd get a negative number. So what was the point of all this? F is decreasing when f prime is negative. That happens here and here. So that matches up with answer choice B. A lot going on in that problem. Number 8. Number 8. 7's a good one, but it's recorded and you can look at it if you need to. Given twice differentiable function f with f prime of 7 equals 0, f double prime of 7 is negative 6, which must be true? Okay, so prime tells me slope, double prime tells me concavity. So if slope is 0, horizontal tangent line, and we're concave down, then that means at x equals 7, there's a relative max. I like those kind of questions. Heavy on the concept, light on the process of taking derivatives and quotient rules and sines and cosines. No, if you understand what's going on, it's an easy question. Number 11. If y equals sine of x plus cosine of x, so much about avoiding sines and cosines, which of the following is true? Local max, local mins, how many between 0 and 2 pi? Well, maximums and minimums, that sounds like f prime stuff. So let's take a derivative and figure out where things are increasing and decreasing. So y prime, first derivative would be cosine of x. Derivative of cosine is negative sine of x. So let's figure out where that's equal to 0. I feel like this is better than some of the ones we've done in the past. I feel like the ones we worked previously, they were off by a sign, a plus or minus. Here I just want to know where sine and cosine are equal to each other. So that should be a little easier, I think. What angles? It's got to be the over 4s. That's all the root 2 over 2s. And then more specifically, where are they both positive or both negative? First and third. So pi over 4 and 5 pi over 4. So that's my only 2 possible answers. So 1 local and 2 local. No, it can't be B because they're not 3 of anything. 2 local maxes, 1 local minimum. That can't be right. 1 max, 1 min, or 2 maxes and no mins. Well, my guess is 1 of each, but let's do the number line thing to make sure. So if I check 0, and I'm checking it into y prime, cosine of 0 is 1, sine of 0 is 0, so that's positive. There's no double roots, so the alternating rule should work. But sines and cosines, maybe I should slow down and not just blindly follow the alternating rule all the time. Cosine of pi minus sine of pi. Cosine of pi is negative 1. Sine of pi is 0, so that's negative. And then 2 pi should give me the same thing as 0, so that should be positive. So that means there's a max at pi over 4 and a min at 5 pi over 4, one of each. So, big picture, y prime tells you where y is increasing or decreasing. Past knowledge is the derivative of sine and cosine and all the trig stuff. By the way, we have time that you can stop and ask questions on these. Like, I'm not just trying to race through. So stop me if you get stuck somewhere. 14. What is the absolute maximum? So alarm bells going off in my head for that. On the interval, more alarm bells. Same alarm bells though. What am I needing to do if it's absolute and if it's on an interval? Check the endpoints. So I know I'll need critical points, and then I'll need to check those critical points, but I'm going to set up my table of values right now and know that negative 1 and 1 are my endpoints. And hey, if worse comes to worse, I could just plug in negative 1 and 1 and pick the maximum of those and hope it wasn't at one of the critical points, right? Better than nothing. Quotient rule. Derivative of the top, derivative of the bottom are the same, so might make things work out nicely for us. Quotient rule. Some people are still missing the quotient rule. I should check to see if it's guys or girls, right? Because if you can't keep the GF first, it's never going to work, right? So my suspicion is that boys have more trouble with the quotient rule than girls do, because girls understand the GF has to come first. So I know you get tired of me saying that, but somehow I've got to get you people to remember that it's GF prime minus FG prime over G squared. And the mistake, the common, I mean, it's 2 or 3 people per class that keep switching the order of those things. And I keep telling them to put the GF first, and they just won't do it. All right, enough sexism for one day. GF prime. So GF prime would be 2t times t squared plus 3 minus FG prime. That would just be 2t cubed all over t squared plus 3 squared. So distribute the 2t. The 2t cubes will cancel, so I'll just be left with 6t over t squared plus 3 squared. And I'm looking for critical points, because critical points are potential maximums and minimums. And so the top is 0 when t equals 0. So that's a critical point. That can go on my table of values. The bottom will never be 0, because if I square something, add 3, square it again, that's positive, positive, positive there. All right, so I've got my candidates. Officially, this is called the candidates test. You come up with your candidates, and then you test them. Where am I testing them into? Because now I got 2 things. I got y, and I got y prime. If I want to find the maximum, which one should I test it into?
Y?
Yeah, because I just want the tallest, highest point. In fact, I already know if I plug in 0, I'm going to get 0 for y prime. So maybe I'd figure it out if I plugged into y prime that that's not what I'm looking for. So into y, not y prime. So 1 over 1 plus 3 is 1/4. If I plug in 0, I get 0 over 3, 0. If I plug in 1, I get 1 over 1 plus 3, also 1/4. And so the question is, what is the value, the maximum value is 1/4. It happens twice, and man, there's all kinds of tricky answers on this. It happens at x equals -1, and it happens at x equals 1, but that's not what the question asks. The question wants the y value. 0 is the minimum, but the maximum is 1/4. So, critical points to get you the potential maximums and minimums. Don't forget the endpoints. Test them all, and then just pick the highest value. Parker.
So for these, it can be the endpoints?
Yes. Yes. If you're thinking MVT can't be an endpoint, that's right. MVT, you can't use the endpoints. But if I want, this just says between -1 and 1, so I can use -1 and 1. Let's see, we'll say 15 for a different class, but you might recall I said that one of the free response questions gave you a table of values and then asked some questions. So that looks interesting. Number 17. The minimum value. Minimum value. So I'm thinking F prime. F prime changes negative to positive. Yeah. Find the value of K. Okay, well, let's find F prime. 4x cubed plus 12x squared. So if I factor out a 4x squared, that leaves x plus 3. So my critical points are 0 and -3. Oh, that's a terrible thing that I just did. I love it when students do that. I did not mean to do that, but that's brutal. You see what the mistake is? And that's why it happens. Like I just wrote them in order, so 0 and -3. Like, no, let's put them on the number line. The whole point of a number line is that it's in order. So let's put the negatives on the left and the 0 on the right. Anything special about one of those that you might catch before we even go much further? It's a double root, so there's not going to be a max or a min at 0. I could be able to use the alternating rule. Let's check -1 into F prime. So square it, I get positive. -1 plus 3 is positive. It's positive on that interval. It's really easy to check 1 or 2 or 3 or 4 because everything's positive. And that's what we expected because that's a double root there. And if I check -4, let's see, 4 times -4 squared, that's going to be positive, times -1 would be negative. And so there is a minimum at -3. Minimum at x equals -3. And the minimum is 7. And we're finding K. So what do I do? The minimum occurs at -3, and the minimum is 7. So plug it in for x. I know it's happening at -3, so let's plug it in. F of -3. Kind of a painful one to plug in here. -3 to the 4th plus 4 times -3 squared plus K is supposed to equal 7. -3 to the 4th, that's 81. 3 squared times 3 squared. Negative 3, oops, that's supposed to be cubed, would be negative 27. Negative 27 times 4. Why are they doing this to me? 81 minus, let's see, 25 times 4 is 100. 2 times 4 is 8, so minus 108. Plus k equals 7. 81 minus 108, that's negative 27. So that was kind of some annoying arithmetic in there. But I got an answer that's there, so I feel good about k being 34. Number 20. Here's the long set of problems where this is the graph of g prime, not the graph of g, so be careful on this section. The graph of g prime, the derivative of g, is given on the right. Right? We do not want you to miss the fact that this is the graph of the derivative, not the graph of the original. On the interval 0 to 8, so it stops at 0 and 8, and then answer all these questions, and we'll answer 20 and 23 and 26. So we'll get a bunch of them. Number 20. At what values of x does g have a relative minimum? Justify your answer. Well, I like justifying first because then I know what to look for. So g has a relative minimum when g prime minimum does that when g prime changes negative to positive. There's going to be some people that say the answer is 6 because that's a minimum. You're like, well, that's a minimum of g prime, and that's not what we want. We want where g prime changes from negative to positive. So g prime, negative is below the axis, positive is above the axis, so that change happens at x equals 7. Number 23. What is g double prime of 3? G double prime, but I don't have a graph of g double prime. I have a graph of g prime. How do I get g double prime if I'm looking at the graph of g prime? Noah, what are you about to say? Slope? Yes. A prime means slope, so you could think of like one of those primes means slope of g prime. So g double prime is the slope of g prime. It's also the concavity, but that's not really what this question's about. So the slope of g prime at x equals 3. So that slope there, I'm going to call it m rather than dy dx because it's the second derivative of g, it's the first derivative of g prime, but it's the slope is negative 1. So the slope of that graph, meaning the derivative of this graph, is negative 1. So it's another one of those questions. It's concept only, no calculations, no quotient rules and sines and cosines and stuff. Just do you understand that g double prime is the slope of g prime? Number 26. At what values of x does the graph of g have a point of inflection? That would be where g double prime changes signs. Let me back up. Point of inflection is where g changes concavity And that's where G double prime changes signs. But I don't have G double prime, so what's another way to say G double prime? Slope of G prime. So you don't have to write all of that out. You got to write some of it out because it says justify. So if you just skip straight to slope of G prime changes, that'd be fine. But your brain kind of has to walk through the other steps to get there. So the slope of G prime changes. Let's see, the slope of G prime changes. Go look at the graph. And I guess I should be more specific. Changes positive, or changes signs. I got it. So it's negative to positive at x equals 6. The slope changes negative to positive. So there's a point of inflection at x equals 6. There are lots of given the graph of G prime questions on the test. Make sure you're good with those. 29. The graphs of the derivatives of the function of f and g and h are shown above. So those are all derivative graphs. Which of the following have a relative maximum between a and b? A relative maximum is where f prime changes positive to negative. So changing from positive to negative between a and b happens right there for f. For g, it changes negative to positive, but it never changes positive to negative, so no on G. And it never changes on H, so that's out. So it's F only. Another one of those, look at the graph of G prime and answer some questions. 29 plus 3 is 32. Are we going to finish? I don't know, it'll be close. 32. For what value of k, we already did one of these, will x plus k over x have a relative maximum at x equals negative 2? Relative maximum, f prime changes negative to positive. Nope, other way around. I can't get the question right unless I do the hand motion with it. Yeah, positive to negative. So I would take a derivative, 1 plus, I see that as kx to the negative 1, so I'm going to make that negative kx to the negative 2. And so that's 1 minus k over x squared. And if I want that to equal 0, then at negative 2, 1 minus k over 4 equals 0. Whoops, I said 4 and wrote 4. So 1 minus k over 4. K's got to be 4 for that to work. We're running short on time, but we're also switching to concept-heavy questions here. 35, inflection points. That would be where f double prime changes signs. So my first reaction is, bummer, I've got to take a second derivative. But my second reaction is, what do I like about what they gave me? What did they give me? The second derivative. Like, they did the hard work for me. Now I need to think about where this thing changes signs. There's a double root, so no change there. So 0 and negative 1. Because 2 is a double root, so it wouldn't change across that one. That was a quick one. 38. in 3 minutes or less. It's another graph of f prime problem. Find all the values at which f has a relative maximum. F prime changes positive to negative. I can't do it without the hand motion. So that happens at x equals -3, positive to negative, and x equals 4. Point of inflection, that would be where these, we did this already, the slope of f prime changes signs. So it changes at -4, the slope of f prime, at -1, at x equals 2. Concave up, that would be where slope of f prime is positive and f prime is positive. So this would be like that overlapping number line thing. I'd have to answer both of them and see where both of them are true. Slope of f prime is positive from -5 to -4, from -1 to 2. F prime is positive from -5 to -3, and 1 to 4. So if I take the overlap of those two things, it would be from -5 to -4. It's hard to do without actually drawing a number line. And I can't, and from 1 to -1 to 2 and 1 to 4, the overlap is 1 to 2. I got to visually see it there. So that was kind of tricky, but just because you're putting two answers together and trying to see where they overlap, and it might have been better to draw it out to begin with. Okay, so that's a third of them. A third of them are already posted. These third will be posted, and then I'll post the final third later.